Biot-Savart law. First of all, before coining this word, we have to see the physical phenomena. In this phenomena, we want to find the magnetic field due to a current carrying wire. Okay, so randomly we are going to take a current carrying wire. So this is the current carrying wire, and it is just like a random. Whatever we say, it is not fixed. And I want to find the magnetic field at the point P. Okay, and the direction of current like this, upwards. So we already know what is the value of the magnetic field at P due to these all system. So it is very difficult to find comprehensively. Therefore, it is better to break it into a infinitesimal part. Means we have to cut into a part, and that part may be like this. This is the a small current element here. We are going to write it. That is the DL. Okay. So this is the total length if L. Then this is the DL. We can write here. This is DL. DL. Okay. And current flowing through the wire is I. It's okay. So what is the way? We know the direction of current, how we find direction of magnetic field, how we find. So first we have to put our finger, thumbs in the direction of current, and then just make a curl. The right hand curl rule like this. The forefinger direction show the direction of magnetic field. So what we see, the direction of magnetic field must be inward like this. So this is the inward direction. And this is the infinitesimal small element of this total. Means that the total length is divided with the multiplier of DL. So the small, all DL are divided. It is very small. So first of all, we want to calculate magnetic field due to this infinitesimal small element. After that, we summing these all through the integration or by the integration. So it is our concept. So first we write here like this. This is the point we have to find. Okay, and this is the R vector, and this is the current flowing direction. So what is the direction of this? So we know tangent at a point is the direction of flowing current, means IDL. Okay, so the direction of DL is along the I, and what is the tangent? This denote the direction of IDL, and this is the theta. It's okay. So what we have to do? This is the inward. What is the way? Because we know there is a plane. This black ball is nothing but plane, but the field go into the plane. So in which product or in which mathematical operation we got such kind of situation where the resultant be perpendicular to the multiplying of two quantities, means perpendicular to the surface. Okay, so you watch, we already knew about it, just like this is the x-axis and y-axis. So multiplying of both give the z-axis. What is the rule? So we know x cross y. Okay, so x cross y, if this crosses here, then the thumbs tell the direction of perpendicular on this line xy plane. Okay, therefore this situation is occurred here. So we can write dv due to the dl. Okay, because this is the small, therefore we take a small. So dv is what? db equal to vector quantity, it is inside, and because first we write about it, mu naught 4 pi epsilon naught I into dl. Okay, vector quantity cross r vector. This is the cross product. Why? Because our resultant be into the plane or out of the plane, so only one operation in mathematics, that is the cross product, which give the value which is perpendicular to the both multiplier, and we can write 3 like this. So this is the mathematical operation of the Biot-Savart law. Okay, so just you watch here again what we have to do. हमने इसको कैसे देखा बच्चे, बायोट-सावर्ट लॉ हम आज पढ़ रहे हैं। इसमें हम क्या देखेंगे कि एक कोई भी करंट कैरिंग वायर है, एक वायर है, इसमें करंट फ्लो कर रहा है, इसके वजह से किसी पर्टिकुलर पॉइंट पे हम मैग्नेटिक फील्ड निकाल रहे हैं, ये पी पॉइंट है। तो हम क्या करेंगे, ये इतने बड़े तार का कैसे यहाँ पे लेंगे, तो इस तार को हम छोटे छोटे टुकड़े में काटते हैं, और जो सबसे छोटा डिस्टेंस होता है इसको हम डीएल मानते हैं, और समझो ये सारे तार डीएल 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 कटा हुआ है, और ये जब सबको सम करेंगे इंटीग्रेशन लेकर के तो फिर पूरा एल पे आ जाएगा, जो कि इस पे हमें वैल्यू देगा। तो हम छोटे एलिमेंट की वजह से निकाल रहे हैं, तो ये है, ये आई का दिशा है, अब इस पॉइंट से निकाल रहे हैं, इस पॉइंट से हम एक टेंजेंट खींच देंगे, ये टेंजेंट का डायरेक्शन और जो ये डायरेक्शन है आर का डायरेक्शन, इसके बीच में एक एंगल बनता है। तो हम देख रहे हैं कि ये जो मैग्नेटिक फील्ड है अंदर की तरफ है, यानी कि इस लाइन और इस लाइन के मल्टीप्लाई, ये पूरा ये ब्लैक बोर्ड के अंदर जा रहा है। तो हमारे पास एक मैथमेटिकल 11th में पढ़े थे हमने, जो स्केल वेक्टर प्रोडक्ट और स्केलर प्रोडक्ट, यानी क्रॉस प्रोडक्ट और डॉट प्रोडक्ट। तो ये जो क्रॉस प्रोडक्ट है, जो वेक्टर प्रोडक्ट है, ये हमें परपेंडिकुलर होने का एहसास दिलाता है। जब दो क्वांटिटी को हम मल्टीप्लाई करते हैं, क्रॉस प्रोडक्ट करते हैं, तो इसका रिजल्ट हमेशा इसके परपेंडिकुलर होगा। तो ये जो है इस पूरे फेनोमेना को जो है दर्शाने का एक बेहतरीन मैथमेटिकल टूल है, कि जब दो चीजों पे कोई परपेंडिकुलर हो तो इसको इस तरह से हम लिखते हैं। मैं आशा करता हूं कि आप सारे बच्चे समझे होंगे इसको। आइए हम फिर इसको आगे देखते हैं, और इसको हमने कैसे लिखना है। तो ये जो है डीबी जो है डायरेक्टली प्रोपोर्शनल, जितने भी इसका करंट होगा इसमें, और जो ये होगा, और जो मल्टीप्लाई इसको हम करेंगे क्रॉस प्रोडक्ट में, तो ये सारे क्वांटिटी का ये क्या होगा, डायरेक्टली प्रोपोर्शनल होगा। और ये प्रोपोर्शनलिटी कांस्टेंट हम लेते हैं, ठीक है। यहाँ पे जो म्यू नोट है हम पहले से जानते हैं, ये क्या है, परमीएबिलिटी। परमीएबिलिटी क्या होता है, ये सपोर्ट करता है, यानी कि जो एयर में है, जब एयर में जिस मीडियम से ये जा रहा है, उस मीडियम में मैग्नेटाइजेशन होगा, और फिर वो मैग्नेटाइजेशन कितना मैग्नेटिक फील्ड खुद में पैदा करता है, उसी को परमीएबिलिटी कहते हैं, ठीक है। यानी कि ये सपोर्ट करता है, जस्ट ऑपोजिट ऑफ द परमिटिविटी, जो हमने पढ़ा था एप्सिलॉन नॉट, इसीलिए 1 होता है एप्सिलॉन नॉट, इसके कोरेस्पॉन्डिंग होता है, ठीक है। यहाँ तक समझ गए, ये हमारा चीज है। अब इसको हम आगे देखते हैं, तो जरा इसको let us come and we break it. So how we have to write, this is the B, and B equal to what, mu naught upon 4 pi, and then IDL, and this is the, we know already what is the formula of this, IDL into R sin theta. Sin theta is the angle between IDL and R, this theta, and this is like this as anti-clockwise moving, and then when we rotate it like this, the thumbs go inside, and therefore it is inside, okay, and then it is the RQ. So what we got, dB equal to mu naught 4 pi IDL, this is the scalar quantity, now it is a scalar quantity, so both are cancel out, and it gives the 2. So what we got, IDL sin theta upon R square. We can tell this is the just like a scalar quantity like this, okay. We have to write this is the scalar, this is the vector form, okay. This is the vector form, and this is the real form, vector form of Biot-Savart law, and this is the scalar forms of Biot-Savart law. So we can write here a scalar form of Biot-Savart law. So both are Biot-Savart law, okay. Form of Biot-Savart law like this, okay. You have to write. So both are like this. Now we see we have to implement it है कि find the magnetic field at the center due to this arc. Okay, this is the question number first, and after that the question extended and also ask us that find the magnetic field here due to this total curve. So first we find it and then second we find by the all. Are you getting me? So come on, तो हम इसको देखते हैं। पहले हम ये छोटे से कर्व का निकाल लेते हैं क्या होगा, और उसके बाद हम टोटल निकाल लेंगे। ठीक है, तो अब इस कर्व को हम पहले बाहर निकाल। सो फर्स्ट ऑफ ऑल यू कंसंट्रेट ऑन द दिस पार्ट। ओके, वी हैव टू फाइंड द magnetic field due to this curve first. So what is the angle? This is the angle theta. We take the theta, whatever we, this is the theta angle. Any problem? First case. Second case we write here for this what? Because we have to find at the center, and therefore this is the a current carrying element. Clear? And we have to find here, this is the P point, magnetic field. So first we start, we just break down it. This is the, this curve is here now. So break down it or cut it into the infinitesimal element. So this is the DL, a small DL. If this is the total L, this is the DL. Are you getting me? Current flowing through it, that is the I current is flowing. So we have to find here what? Magnetic field. So if current is like this, you think, then here the current is upward, out of page, out of blackboard, and in this side it is the inward. Okay, so try to think what I want to tell you. So first of all, we have to find the magnetic field due to this small element IDL at this point, and then we summation, we take the summation, then we add these all through the integration. Okay, so we got the answer. What is the magnetic field due to this total arc? Okay, so this is the arc, we are going to take it. Suppose what we have to do, so this is the infinitesimal small, so we draw a line. Okay, this is like this. Wait. Okay, this is the DL, like this IDL here, and this very small IDL. Okay, and this angle is now d theta, because this total is theta. Okay, so this is the small due to IDL, so this is the d theta. Are you getting me? So what is the magnetic field at this point? It may be dB. Okay, so we are going to write the expression for it. First, this is the expression. Second, what we have to do, you watch. So this is the radius is, we have to take R. Okay, so this line is just like IDL. Okay, and this line is the just meeting point, just like a R. Okay, so we are going to write here dB equal to what? dB equal to, again we already knew, mu naught upon 4 pi into IDL cross R means this line, upon what? Upon what? RQ. So this is the expression in the vector form. Okay, देखो तो इसको मैं क्या करूंगा, इसको वेक्टर फॉर्म में लिख लेंगे, ये इसका एक्सप्रेशन है। ठीक है, अब हम क्या करेंगे कि ये आईडीएल क्रॉस आर अपॉन आर क्यू ये हम पहले से जानते हैं, अब इसको हम ब्रेक डाउन करते हैं। तो अब गौर करो, यहाँ पे हम इसको ऐसे भी लिख सकते हैं, जैसे आईडीएल है तो इसको और कैसे लिख सकते हैं, डीएल, ये डीएल को हम कैसे लिख सकते हैं, तो हम पहले से जानते हैं एक पैरामेट्रिक इक्वेशन होता है हमारे पास, थीटा इक्वल टू एल अपॉन आर, ये आर्क है और ये क्या है, ये रेडियस है। तो यहाँ पे डी थीटा इक्वल टू क्या हो जाएगा, डीएल अपॉन में आर, यानी कि ये आर कैपिटल आर है, इसको हम आर लिख देंगे, ठीक है। तो डीएल अपॉन में आर लिख देंगे, तो यही हो जाएगा ना एल अपॉन आर। अब ये डीएल इक्वल टू क्या हो जाएगा, इंप्लाइज दैट डीएल इक्वल टू आर डी थीटा हो जाएगा, है कि नहीं। तो हम इसको यहाँ पे रख देंगे, तो ये हो जाएगा डीबी इक्वल टू राइट इट म्यू नॉट अपॉन 4 पाई एंड देन आई डी एल. This is the cross product. What is the angle between both? This is the 90 degree. So angle between, because it is passage through the center, and therefore tangent and normal both makes in 90 degree. We already know from the starting class age. This is the tangent and this is the radius. So it makes always the 90 degree, because in mathematics term in circular we know this is the normal and this is the tangent. So tangent is only those line which makes 90 degree with the normal. So we account here sine theta equal to 90 degree. So IDL R into sine 90 degree upon RQ. It's okay. So mu naught upon 4 pi IDL, this R is cancel, a square remaining here, and sine 90 means how much? 1. So it is 1 upon R square, like this. Again we have to write, this is the mu naught upon 4 pi and then IDL. So instead of DL we can write here R d theta upon what? R square, means this R convert into R, because this R like this. So it is better to write it R square, RQ. This is the R, because it is the radial distance. Therefore, we can convert it later, but it is better to write in the starting. So this is the R and this is the R square. Are you getting? Like this. Okay. So what we see? We see dB equal to mu naught 4 pi I R. This is the R, this is the R square. So both are cancel out. So d theta upon R, like this. Okay. So now we are going to take the integration, because both are in the differential forms. We take integration of this and integration of these all. We have to write this. Okay. I write it capital I. Okay. Whatever be, it's I, right? R d theta. What we see? We see mu naught is constant, 4 pi is constant, I is constant itself because current flowing through the wire is constant. This is the radial distance, means radius, which is also constant. So the rule of what? The integration is that all constant term come out from the sign of integration. Okay. So we have to take the outside it. Okay. So we take, and what is the, this is the 0 to theta, because we have to find the total. First we treat it as a small element, after that we take integration, we add sum up these all through the integration. So 0 to theta, we have to write 0 to theta. So right, this is the dB. And now you watch, here is due to these all line flowing current, all have the upward. So there are no component due to these all current at the each point, all what makes the magnetic field at this point, produce the magnetic field at this point out of the page. So only we have to add, there are no any component, because these all are in one direction, that is the outward, due to these all. So we have to integrate, sum it. So the dB is the differential form and integration is the summation form. So total is the B at the center. Okay. And then the constant term mu naught upon 4 pi, and then I upon R is came out, and this is the d theta 0 up to theta. It's okay. And then what we have to do, we have to write mu naught upon 4 pi R I, and this is the theta. So theta is here, and because a small, just like a total theta, and lower limit 0, upper limit is theta. So put theta minus 0 means again theta. So finally what we got? We got mu naught I 4 pi r, okay, and then it is the theta. Okay, so write as a numerator, this is the theta. So this is the magnetic field at the center due to this theta. Now we able to find the magnetic field due to this arc at the what, at the center. तो देखो इस तरह से हमने क्या किया बच्चों, सबसे पहले हमने इसको जैसे तैसे जो हम लिखते हैं लिख दिया, फिर मैं इसको ब्रेक डाउन करता गया। देखो आईडीएल क्रॉस आर अपॉन आर क्यू, ये बायोट सावर्ट का लॉ है। फिर मैंने इसको रखा आईडीएल आर, बिकॉज आईडीएल और आर के बीच में, ये तो रेडियस और टेंजेंट के बीच में हमेशा 90 डिग्री होता है। हम जानते हैं बचपन से, सर्कल के चैप्टर में भी पढ़े थे कि नॉर्मल और टेंजेंट 90 बनाता है, तो 90 लिख देंगे। तो 90 डिग्री का मान 1 होता है, ये आर है, आर से आर कैंसिल हो जाएगा, क्यू तो ये सिर्फ आर स्क्वायर बचेंगे, और म्यू नॉट अपॉन 4 पाई इस तरह से है, आई डीएल 1, ये आर स्क्वायर आ जाएगा। फिर बी इक्वल टू क्या होगा, म्यू नॉट आई। अब डीएल जो है यह छोटा सा एलिमेंट है, तो इसको हम क्या लिखते हैं, थीटा इक्वल टू एल अपॉन में आर। बचपन से पैरामेट्रिक फॉर्म है ये, हम इसको जानते हैं, कभी पैरालेक्स फॉर्मूला में भी पढ़ा होगा इस तरह से, जब 11th में पैरालेक्सियल मेथड टू फाइंड द डिस्टेंस फ्रॉम द फार अवे, so such kind of concept also used there, but previously you already know from the trigonometric that the in circular case theta equal to arc upon the radius. It is well known and well defined things, okay, in mathematics. Therefore we have to put here, and तब हमने क्या किया बच्चे, db equal to mu naught 4 pi I r d theta upon r square, r से r कट जाएंगे, r बच जाएंगे, हमारे पास d theta आ गया, db आ गया। यानी कि जब b होगा, ये सारे कांस्टेंट I है, r है, ये सारे इसमें जो ज्योमेट्रिकल चीज है, इसमें I भी करंट जो है कांस्टेंट फॉलो कर रहा है। तो अब इसका इंटीग्रेशन लेंगे, dv का इंटीग्रेशन जो लेंगे तो ये लेंगे, और इसका थीटा का 0 से थीटा तक लेंगे, क्योंकि यहां से शुरू करता है ये, अगर इसको अगर स्वीप करते हो यहां तक तो 0 से थीटा तक आता है, तो इसका लोअर लिमिट ये, अपर लिमिट ये है। इस तरह से जब हम करेंगे ये सब, तो ये b आ जाएगा। इसको भी कह सकते हैं 0 से लेके b तक, लेकिन समझ सकते हो, लिख भी दोगे तो चलेगा, तो ये b ही आएगा यहाँ पे, म्यू नॉट अपॉन 4 पाई I अपॉन आर, 0 से थीटा, और ये डी थीटा म्यू नॉट आई 4 पाई आर थीटा, ये अपर लिमिट माइनस लोअर लिमिट रखोगे तो थीटा ही आएगा। इस तरह से बी इक्वल टू म्यू नॉट आई थीटा 4 पाई आर, ये हमारा टोटल मैग्नेटिक फील्ड है, जहां की थीटा भी दिया होगा, आई भी दिया होगा, आर भी दिया होगा, एंड दिस इज द यूनिवर्सल कांस्टेंट इन द केस ऑफ व्हाट वी गॉट फॉर्मूला, बी इक्वल टू व्हाट, म्यू नॉट आई थीटा अपॉन व्हाट, 4 pi r. So this is the standard forms. Now you think, what is the magnetic field when theta is 90 degree, theta is pi? Just you think, very very important, because this term is theta and this is the r. So suppose if I want to find the magnetic field due to a quadrant, so we have to put theta equal to what, pi by 2. Similarly, if you want to find the magnetic field due to this semicircle, then semicircle means what, theta equal to pi. You have to put pi here. If you want to magnetic field due to the semicircle plus quad circle means 3/4 of circle, then what we have to put, this is the pi and this is the pi by 2, so it is the 3 pi by what, this is the 3 pi by 2, pi by 2, pi by 2, pi by 2, 1 pi by 2, 2 pi by 2, 3 pi by 2, because all quadrant is 90 degree, and you multiply 1 2 3 portion, so 3, if you multiply 4 you got the 2 pi up to this. Therefore we want to calculate the magnetic field due to this 2 pi, because total angle is how much, 2 pi. So you write here, this is the 4 into pi by 2, because pi by 2 is 1 quadrant, 2 quadrant, 3rd quadrant, 4th quadrant, therefore 4, you cut it, you get 2 pi. So we have to put here 2 pi. So magnetic field at a center, what? Mu naught I upon 4 pi r theta equal to 2 pi. Are you getting me? Pi is cancelled, 2 is cancelled. So what we got? Mu naught I upon 2r. So this is the standard form. Magnetic field at a center due to a circular loop or circular coil, what we get? Mu naught I upon 2r. This is the standard formula. Okay, you think finitesimal small current dispense, that is dl, just cut these all. Okay, and then we integrate this, and then we just sum up through the integration these all, we get the answer here. Okay, so you think what may be here? Okay, it is in your hand. This is the distance x, this is the standard distance, means radius of coil is r, and this distance we can treat as a z. Okay, so z is imaginary, not given, only a standard form is that r is given, x is given, I is given, and even this dl is not given. This is the our consideration. We consider this is the smallest, only the r and x is given here. We have to express our final result in terms of r and x at here, and then we see in extended forms at the center how we got the magnetic field. We already find out in spite it through this formula. Again we will see what is the magnetic field physically. Visualize this the ring, just like a bracelet, whatever you are bearing as a bangles bracelet, girls bearing in our home. So this is like a bracelet. This is the tip like this, and we are going to demonstrate through it. Okay, so this is just like this. Okay, we have to find. So what we see, this is the axial point, this is the axial point, means this is the central point, and just a stretch it here. We have to find magnetic field at this point. Okay, at this point, just a stretch here, put here at this point, due to this current carrying wire, and current is flowing through this way. Okay, so just we think current flowing through this way. At the topmost, dl is just you draw a tangent, so just tangent come like this vertically. Okay, you understand what I want to tell you? So idl is just like a horizontally, not vertically, sorry, it come horizontally directly. So direct it come like this here. Okay, and then what we see, this is the direct, and this is the, it is not at p, but p, imaginary p is here. So this line like at this point like this. Okay, now we gradually decrease here because I have to find here, but this is the region. Suppose it is the parallel to the x-axis here. First time we draw a imaginary line, and this line is here, but gradually we're going to bend it up to this point. So this angle is theta, but you just think this is the r, means z, we consider this is the z. So ideal is in this direction, and z in this direction. So what is the angle between ideal and z? Ideal and z, you think this one is z. Okay, you see, and this is the ideal. Are you getting me? What is the angle? 90 degree. Both angle, both have 90 degree. Okay, this is the current. You have yellow color is current, and this direction is the direction of z. Now you put here, and we have to bend it below, because like this. Okay, so now what is the angle between z and ideal? Again you see 90 degree, because this is always in a straight come out, and this is the either be horizontal or be bent down, but angle between both is always 90 degree. So this angle ideal and z has how much? 90 degree. I want to visualize it through this figure. This is the 90 degree. As you watch, this is the current carrying wire, and this is the z. Okay, like this you see 90 degree. It is clear. But now we just going to bend it. Bend, after bend you again see this is the 90 degree. There are no change in degree, because it is just like a rotate. Therefore the angle between both is constant, always 90 degree. So what I want to convey, I hope you understand my lectures. This is the z and this is the I. so both have the 90 degree. Okay, so we are going to write, देखो इसमें दोनों में ये हो जाएगा, ये देखो रिंग है, रिंग में करंट ऐसे आ रहा है इधर से, और ये क्या है, ये जेड एक्सिस है। तो देखो दोनों के बीच में कितना एंगल बन रहा है अभी, मान लो जेड एक्सिस ये अभी हॉरिजॉन्टल में है, तो ये देखो ये कितना बन रहा है, ये जो है 90 डिग्री बन रहा है, मैंने विजुअलाइजेशन करके दिखा दिया। अब क्या करो, तुम इसको नीचे बेंड करो, कर दिया। जब नीचे तुम बेंड करते हो तो अब भी देखो ये 90 ही डिग्री है, क्योंकि ये बेंड कर रहा है तो करने दो ना। ये एक ऐसा कंडीशन है कि ये तार है, इसके चारों साइड ये घूम रहा है, ये घूम रहा है, मतलब अभी ये सीधा है, ये लाइन सीधा है, अब ये घूम के नीचे जा रहा है, जाने दो, फिर भी दोनों के बीच में तो 90 डिग्री होगा ना, ये चारों साइड घूम भी जाएगा तो 90, जरा सोचने की कोशिश करना। तो यही नीचे आया है, तो जो यहाँ से जो डीएल सीधा आ रहा है, अभी इधर के डायरेक्शन दिखाऊंगा ये, और जो ये है इसके बीच में कितना एंगल होगा, 90 डिग्री। तो पहले इसका हम लिखते हैं, क्या लिखते हैं, व्हाट द फॉर्मूला at this point, this is the z, this is the r, so you write db equal to what, db equal to, we know mu naught upon 4 pi I dl cross. Now don't think about it, because we have to find this, the current element, and this is the line of joining. So this is the r, we have to think about z upon what, r square, a zq, like this. This is the vector form. Are you getting me what I want to tell you? So this is like this line means ideal, and same times must be perpendicular to this line. So this line is perpendicular here, you put here, so this is now perpendicular this also and this also. So magnetic field is just like a all sides like this. Okay, like a funnel keep. So this is the direction. I hope you understand what I want to convey. Are you getting me? And this is the, now we're going to delete it, this line is not useful. How you we reach up to this point by the help of this, only for the understanding of these things. Okay, I hope you understand. So due to this ring, this is the direction of magnetic field, each had two direction. This is the, suppose this is the theta angle. Okay, theta angle. So this angle is the y-axis, suppose, and this is the z-axis, oh sorry, x-axis. Okay, x-axis. So the component of this magnetic field is two, y-axis and x-axis. So what we see in y-axis, this is the upward, and in the due to this y-axis and due to this symmetrically, this is the downward. So both are cancelled. So y-axis is cancelled. So by is what? By equal to 0. Only the x-axis, yani bx has value we have to count. Okay, so bx is what? Bx is just like this. So this is the theta. So what is the value of this? This is the parallel to the x-axis. So this is the sine theta, you know. So this is the b, real b, and this is the theta, and this is the bx. So bx is what? So we write simple, this is the sine theta equal to what? You write here sine theta equal to perpendicular upon hypotenuse, bx upon b. So what is the bx? Bx equal to b sine theta. I hope you understand. So here dB is nothing but we have to find, this is the dBx. So dB, this is the dB. Now we extend it from this formula. Okay, try to understand. This is the simple formula we write here, but there is a no suitable one-to-all quantity available here. Now I am going to write. So dx is equal to, this is the dB sine theta. Hello. So dB is how much? dB is like this. So you write mu 4 pi and then IDL cross Z upon ZQ, and this is the sine theta. Sine theta. I hope you understand what I want to tell you. The angle between IDL and Z is always 90 degree. I know. Therefore, we are going to write it in the breakage forms. So you write mu naught upon 4 pi IDL, and this Z is now multiply form. So you write the only magnitude into and sine 90 degree, because what we see here, IDL Z is cancel. So this is the Z square, sine 90 is 1, and this is the sine theta. Are you getting me? This is the IDL. It's clear, and this is the Z square. So up to this point I think you understand. हमने क्या किया, यहाँ पे कुछ भी नहीं किया, सीधा ये फॉर्मूला लिखा, स्टैंडर्ड फॉर्मूला यहाँ से। उसके बाद डायरेक्शन देने की कोशिश करी कि इसका जो फील्ड का डायरेक्शन इधर होगा, ये कीप की तरह से सिमेट्रिकल चारों साइड एक हो जाएगा, ठीक है। तो अब इसका जो अगर एक कीप की तरह ये चारों साइड है, ये लाइन एकदम घुमा घुमा के है, ऐसे जैसे कुल्फी वगैरह खाते हो ना, सॉलिड एंगल ये बना रहा है ये। तो इसके वजह से जो जेड एक्सिस होगा ये प्लस में होगा, ये माइनस में होगा, कैंसिल हो जाएगा, एक्स एक्सिस सबका समेशन हो जाएगा और ये एक्सिस होगा। तो एक्स एक्सिस के पैरेलल में क्या है, साइन थीटा, इसको हमने थीटा माना है। तो ये देखो यहाँ से है। अब हमने इसको क्या, साइन थीटा इक्वल टू, हम जानते हैं कि ये परपेंडिकुलर अपॉन हाइपोटेनस होता है, बी एक्स इक्वल टू ये होता है, ठीक है। तो ये सारा चीज यहाँ से है, और इसको बनाए रखना हमारा जो है फाइनल डीबी जेड के टर्म में, सॉरी डीबी एक्स के टर्म में, यानी कि इस रास्ते पे जो है इस जगह हमारा ये फॉर्मूला आ चुका है। अब आया है, जरा इसको देखें तो हमें जेड तो है नहीं, हमने डीएल तो अभी लिखना है, चूंकि आर दिया हुआ है, सबको बदलते हैं। हमने साइन थीटा तो यहाँ पे है नहीं, हमारे क्वांटिटी सिर्फ आर एक्स है। तो हम क्या करते हैं, ये सारे को कन्वर्ट करते हैं गिवन क्वांटिटी में। ओके, क्यों 90 डिग्री है, गौर करो, ये मैग्नेटिक फील्ड है और ये जेड एक्सिस है। जब सीधा था तब भी 90 था और ये अब भी 90 है, तो ये 90 माइनस थीटा ये एंगल हो जाएगा। तो अब ये जेड वाई एक्सिस है और ये एक्स एक्सिस है, तो ये भी तो 90 डिग्री होगा। इधर देखो ये भी 90 डिग्री होगा टोटल, क्योंकि ये 90 माइनस थीटा, इसका मतलब इंप्लाइज दैट दिस इज आल्सो थीटा, यानी कि ये थीटा इसके बराबर हो जाएगा। समझ रहे हो कि नहीं, ये थीटा। अब देखो हमारे पास ये थीटा आ गया। अब यहां से साइन थीटा का मान कैसे लिख सकते हैं, साइन थीटा इक्वल टू परपेंडिकुलर अपॉन हाइपोटेनस, यानी आर अपॉन जेड लिख सकते हैं। तो ये साइन थीटा तो यहां से खत्म कर देंगे, जेड तो जेड स्क्वायर है तो आर स्क्वायर एक्स स्क्वायर आ जाएगा। अब बात रह गई डीएल का, तो अब इंटीग्रेशन करना पड़ेगा, तो इंटीग्रेशन करते हैं। तो टेक द इंटीग्रेशन इन बोथ साइड, bx इक्वल टू इंटीग्रेशन म्यू नॉट 4 पाई, ओके, एंड देन यू राइट IDL upon z square and then sine theta. Okay, so we have write mu naught 4 pi and then sine theta is what we got, we got r by z. So this is the write it, IDL is the a small form, and we have to take integration of this, and z is the constant, distance is constant symmetrically, therefore z is also came out. So z, first you write z square, I upon z square, then sine theta equal to what, r upon z, sorry, r upon z. I hope you understand it, r upon z. And then this is the dl, we have to take integration of dl. Okay, dl is the total length, means 0 to, this is the perimeter of the what circle, 2 pi r, I know already. And therefore now this is the bx, we write bx equal to mu naught 4 pi I, this is the r zq, okay, and then this dl is l, so write l, and this is the lower limit, and this is the 2 pi r upper limit. I hope you understand. Now we have to put here upper limit instead of l, 2 pi r minus 0 means 2 pi r. I hope you understand. So we watch next, we're going to delete it. So what is the formula? Okay, Bx. So Bx equal to what? You write, this is the mu naught 4 pi IR and ZQ. What is the Z? Z is root under R square. Okay, you write here Z is what? Root under R square, or write X square plus R square. This is the value of Z to the power 3. Okay, because 3 is here. And then L equal to, you write 2 pi R minus 0, upper limit minus lower limit. I hope you understand. So Bx equal to mu naught upon 4 pi. This is the IR, and root under means what? If nothing is right here in the third, so this third tell us it is 1 by 2. So X square plus R square, we can write here 3 upon half. 1 by 2 is root under, and this is denoted as a thirds. Okay, and then this is the 2 pi R. Clear? So now you cancel. What is this? 2 say 2 cancel, and then pi cancel. Then what we see here? It is mu naught I R square upon 2x square plus R square 3 by 2. This is the Bx total. Here everything is not of axial line. So you can put here, here x, therefore x, here 0, you put 0 instead of x. So you will get mu naught I R square, and then it is 2, write 0, and this is the RQ R square, and you put 3 upon 2. So 2 is cancel out. What we get? Mu naught I R square, and this is the 2RQ. So R square, R is cancel. What we get? Mu naught I upon 2R. This is the magnetic field at the center of the circle. Okay. Previously, when we find the magnetic field due to the through the arc system with the angle, in that condition we get the same result, mu naught upon I upon 2R. Just recall the previous one, and in this case we also get the same. So our journey is complete. How we get the